The marshmallow test is a classic study in delayed gratification. A child, a treat, a promise of a better reward if they just wait. But what happens when you remove the child and the marshmallow? You replace them with a common cuttlefish in a specially designed tank, and the treats with a choice, a piece of raw king prawn available now. For a cuttlefish, that prawn is an acceptable snack, but it isn't the best. The best is a live grass shrimp, a delicacy worth waiting for. To communicate the rules of the game, researchers led by Alexandra Schnell used a language of symbols displayed on screens next to the tank. A circle indicated that the desired shrimp would be released from its chamber soon. A triangle meant a longer delay was expected, and a square meant the shrimp was unavailable, signaling that the cuttlefish might as well eat the prawn. Incredibly, the cuttlefish learned what these abstract shapes signified. And they waited. The most patient cuttlefish held out for over 2 minutes, 130 seconds, staring at a meal they could eat right away for the promise of something better. During the wait, they would often turn their bodies away from the immediate temptation, a behavioral strategy remarkably similar to how human children distract themselves. This level of impulse control is on par with what we see in large-brained vertebrates like chimpanzees, crows, and parrots. It begs the question, why would an animal with a lifespan of less than 2 years need to be so patient? In primates, patience can be a tool for navigating complex social hierarchies. For a corvid, it's essential for caching food for later. But for a cuttlefish, which is soft-bodied and lacks a permanent burrow, patience is a direct survival tactic. Its life is one of constant exposure. Foraging isn't just about finding food quickly, it's about choosing the right moment to emerge from camouflage, waiting for a predator to pass, or stalking prey that offers the most energy for the least risk. This cognitive ability arises from a nervous system that is fundamentally alien to our own. The last common ancestor we shared with a cephalopod was a simple worm-like creature over 600 million years ago. The cuttlefish brain is shaped like a donut, and the esophagus passes directly through the middle. But that is only the central command. More than 2/3 of a cuttlefish's 500 million neurons are located not in its brain, but in its arms, creating a highly distributed intelligence. Each arm can act semi-independently, capable of making its own decisions about texture and taste. While the central brain might issue a general command like, "Investigate that crevice," the arm itself choreographs the specific movements. This is not a puppet master pulling strings, it is more like a committee of collaborating minds. This decentralized processing allows for incredible multitasking, such as one arm meticulously solving a puzzle to get food, while another probes the sand for a different snack. This complex thinking is broadcast on their skin. The millions of chromatophores, tiny pigment-filled sacs, are not just for camouflage. They are under direct neural control. Their skin is a high-resolution display for their thoughts. They use it to signal intent, to threaten rivals, and to court mates. A cuttlefish can even display 2 completely different patterns on opposite sides of its body at the same time, deceiving a rival male on its left while showing a courtship pattern to a female on its right. This is conditional, strategic thinking, expressed in a language of light and color. The ability to wait for a future reward hints at another sophisticated skill, episodic-like memory. This is the ability to recall the what, where, and when of a specific past event, something we rely on constantly. To test this, researchers gave cuttlefish different types of food in different locations. The cuttlefish demonstrated that they remembered not just what they ate and where they found it, but also when they ate it. They used this information to return to the locations where their favorite food had time to be replenished. This isn't just rote memory. It's a key component of future planning. If you can mentally project yourself backward in time to recall the specifics of a past meal, can you project yourself forward? This capacity for mental time travel was long considered a uniquely human trait, tied to our complex sense of self. For the cuttlefish, it wasn't about planning a vacation. It was about solving the fundamental problem of optimizing the next meal, a simple yet profound form of looking into the future. Perhaps the most astonishing discovery is that this complex, episodic-like memory in cuttlefish does not seem to decline with age. In humans and virtually all other vertebrates, the ability to learn new things and recall specific events deteriorates as the brain gets older. But in cuttlefish, the elderly individuals performed just as well in memory tests as the young ones. Their ability to learn and remember remained perfectly intact right up until the end of their short lives. The intelligence we see in cephalopods is the product of a completely independent evolutionary experiment. Our last common ancestor had no complex brain to speak of. This means that high-level cognition, the ability to plan, to remember, to exert self-control, evolved at least twice on this planet, two entirely separate paths, starting from nearly nothing, diverged for 500 million years, yet converged on remarkably similar solutions to the problem of being a mind in the world. So when you look at a cuttlefish, its skin pulsing with colors and patterns, you're not seeing a simple, instinct-driven creature. You are witnessing a mind that weighs the future against the present, that remembers its personal past, and that thinks in a language of light written on its own body. It forces us to reconsider the very definition of intelligence and to wonder what other forms of consciousness exist right here, entirely unseen, in the world all around us.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.